Good morning. Mr. Herman here with our latest installment in our quadratics notes for Unit 4. So far we've looked at our three forms, standard form, factored form, and vertex form. We've looked at our graphs, we looked at some tables, and now we're going to focus on graphing our quadratic equations. Okay, so graphing quadratic equation is very similar to graphing an equation from a line, in that we can plug in points, but there's a few sort of, I don't call them tricks, but strategies that we can use depending on the form of the quadratic equation that we see. So let's remind ourselves of the key features that are shown in each of our three forms of equation. So hopefully remember from standard form, we want to look at C, and that is our y-intercept. In factored form, we want to look at our D and E values, and those are our x-intercepts. And then our vertex form, we want to look at H and K, and that is our vertex. Okay, so those are the key features that we're going to see from our equations, and we're going to use those as we're graphing our equations today. So the one key thing you want to remember is that when we graph a quadratic equation, always make a chart and plug in values. Okay, so we'll be doing that this morning. We'll look for our key points that we want to graph, but also do some plugging in as well. So if we see an equation in standard form, so remember that's what standard form looks like here, we're going to want to graph the y-intercept, so 0, c. Okay, so my y-intercept here is going to be 0, -5. And I'll put that in my table. Let's see. I'm going to put that in my table down here. Okay, oh, there we go. And just to show you what's going on here, I'm going to plug in 0 for x. And that's going to equal 0 plus 0 minus 5, which is -5. So 0, 1, 2, 3, 4, 5. Okay. Now, let's identify the x value of our vertex. Now, this is something new that we're learning. The x value of our vertex is -b over 2a. Okay? If we recall, a is the number in front of our x squared, b is the number in front of our x. Okay? So, let's go ahead and identify. We know that a is 1. We know that b is 4. So we want -4 divided by 2. Okay, so that means that the vertex of our equation is going to be at -2. So x equals our x value. Okay, so let's put -2 into our equation here. We'll put -2, we'll put it here. Okay, so now we don't know what exactly we're going to get for the output yet, but let's go and plug it into our equation. So we have -2 squared plus 4 times -2 minus 5, and that's going to be, so -2 squared, that's a positive 4. We can use our calculator here, plus -8 minus 5, so it's -13 plus 4, so it's -9. So it's going to go off of our graph a bit. Let's see, so we go 1, 2, 1, 2, 3, 4, 5, and then 6, 7, 8, 9. Okay, I could have picked a better graph, but we're going to work with it. Okay, now what we want to do is we want to go to step 3. We want to make a chart using x values near the vertex, x value. Okay, so let's plug in -1, let's plug in -3, and -4. I always want to have 5 values in my chart. Okay, so let's go ahead and plug in. We'll start with -1. -1 squared plus 4 times -1 minus 5. -1 times -1 is +1. 4 times -1 is -4. And then we have -5. And so that's going to be -9 plus 1, -8. Look at our graph here. So we go -1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, since this is my vertex, we know that we have an axis of symmetry at my vertex. So what's going to happen is that my y values are going to be the exact same. So there's -8, there's -5. Notice how my vertex is -9. I go -8, -5, -8, -5. Okay, so let's go and graph those points on here. So we go -1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And then -1, 2, 3, 4, -1, 2, 3, 4, and 5. Okay, so there's a better graph paper here, but look at that, there's our parabola. Okay, so we've got our parabola there, and that's our standard form. We want to follow that 4-step process. So let's go ahead and look at vertex form and factored form. So look at vertex form first. So vertex form is nice because, well, it tells us our vertex. Okay, so let's go ahead and identify and graph the vertex. So for vertex form, 2, 3. So I'm going to put 2 as my x and 3 as my f of x, because that's my vertex. Let's make a note here, vertex. We'll graph 1, 2, 1, 2, 3. Okay. Now we want to make a chart using x values near the vertex x value. So I know that 2 is my vertex. So let's go 3, 4, and 1, 0. Okay. So let's go ahead and I'm going to stick with the positives here. So we're going to go with 3. So I need to plug it in. So I said 3 minus 2 squared plus 3. So 3 minus 2 is 1. 1 squared is 1. So that's -1 plus 3, which is 2. Okay. If you're using a calculator, make sure that you always use your parentheses here. So negative parenthesis, 3 minus 2 parenthesis squared plus 3. And then you'll get 2 there. So we'll go 1, 2, 3, 1, 2. Okay. Let's plug in 4. So negative parentheses 4 minus 2 squared plus 3. So 4 minus 2 is 2. 2 squared is 4. So -4 plus 3 is -1. So let's graph it. 1, 2, 3, 4, -1. Now, since there's our vertex, we know that our y values are going to be mirrored. It's the same y value. So 1 is going to be 2, 0 is going to be -1. So 1, 2, and then we go 0, -1. Okay, now let's go ahead and connect our dots here. Okay, so we wanted to make sure we identify that vertex first, and then figure out what x values we want to plug in. Go just 1 and 2 away from the vertex, plug in 2 of them, and then you have a mirror image. Okay, now we're going to take a look at our factored form. Okay, so look at factored form here. In our factored form, we want to identify and graph our x-intercepts. So our x-intercepts here, so we have x equals -3 and +1. And those are going to be 0, so we go -1, 2, 3, +1. Okay, so we're going to go ahead and use those as our values in our table. Now, one thing I want us to notice is that we go, let's see, we have 1, 2, 3, 4, we have 4 spaces between here. So what I want us to do is we're going to use our x-intercepts in our table. But what we also want to do is we want to figure out the middle of our x-intercepts is the x value of our vertex. Okay, so x-intercepts, or so the middle of x-intercepts is the x value of the vertex. So we'll see that in a second. Okay, so what we're going to do here is we're going to go -2, -1, and 0 in our table. Now we know that the output for 1 is 0, the output for -3 is 0. Okay, so notice how we're starting to see there's that mirror image. So this middle this middle value, I'm going to have this plug it in first here. So -1 plus 3 times -1 minus 1. So -1 plus 3 is going to give us 2. -1 minus 1 is going to give us -2. And that's going to give us -4. So let's graph -1, 1, 2, 3, -4. There's our vertex. Notice how it's going to start to have a mirror image on each side. If I go 2 to the right, I'm at 0. 2 to the left, I'm at 0. Let's plug in 0 here to figure out another output. So 0 plus 3 gives us 3. 0 minus 1 gives us -1. So there's going to be -3. And that means that we're also going to have -3 up here. So 0, 1, 2, -3. -1, 2, -1, 2, 3. And then we can connect our dots. Okay? So, as you'll notice, we did not end up having to plug in a whole lot of points. Okay, we need to focus on those key features, use those key features to help us save some time when we graph our quadratic equations. Okay, so now if we're not sure, whenever we are not sure what to do for our graph, what we can always do is we can always pick 5 x values, plug into the equation, like we did up here. You plug into the equation, graph the points, and you need to connect the points. And what shape are those points going to make? They're going to make a parabola. Okay? So, you'll have access to a calculator, but we do want to make sure that we know how to graph without using the calculator to graph the function. So if we use a calculator to plug in the values, that's fine. But when we're graphing the function, we do want to think about how can we make a table and do the points and use our key features to help us graph the parabola.